If our sun were suddenly replaced by a magnetar, Earth wouldn't stand a chance. We'd be incinerated almost instantly. Magnetars are extreme cosmic leftovers, incredibly dense and compact objects created when massive stars explode in supernovae. Even though they're small, just about 20 kilometers across, they cram in about 1.5 times the sun's mass. What makes them especially terrifying is their magnetic field, which is billions of times stronger than anything we can create on Earth. This little star, despite its size, would destroy everything on our planet. In this reimagined journey, we're exploring what would happen if we swapped the sun with some of the universe's most extreme and bizarre objects. Strangely enough, some of them could actually be more beneficial than the sun, but many would spell disaster. Before we dive into the lineup, think about this. If you could replace the sun with anything in the cosmos, what would it be? Drop your thoughts in the comments. We'd love to hear your picks. Let's begin with a red giant. Spoiler alert, it's not good news. Eventually, the sun will naturally evolve into a red giant, swelling up and engulfing the inner planets, including Earth. But don't panic just yet. That transformation won't happen for another 5 billion years or so. Right now, our sun is a G-type main sequence star, a relatively stable kind of star that burns hydrogen in its core to produce energy. It's been shining for about 4.6 billion years, and scientists estimate it has about 5 billion more years before it exhausts its hydrogen and begins to die. When that happens, the sun will expand massively, becoming a red giant. But what if we swapped it out now? If a red giant replaced the sun today, Earth would be destroyed in an instant. The red giant's enormous size would engulf Mercury, Venus, and then Earth without giving us a moment to appreciate the view. Now, here's something surprising. Red giants are actually cooler than the current sun. While our sun's surface temperature is around 5,772 Kelvin, about 5,500 degrees Celsius or 10,000 degrees Fahrenheit, a red giant's surface is only about 3,000 Kelvin, or 2,700 degrees Celsius or 4,900 degrees Fahrenheit. But don't let that fool you. The sheer size and brightness of a red giant would be catastrophic. These swollen stars can grow to be 200 times larger than the sun and shine up to 5,000 times brighter. The brightness alone would blind you if you looked up. The sky would turn a blazing orange, and Earth would be hit with a heat wave so extreme, global temperatures would spike by hundreds of degrees in minutes. The oceans would boil away almost instantly. Then, Earth itself would be pulled into the red giant's outer layers, where the crust would melt and every trace of life would vanish in a matter of minutes. Earth would be consumed, and nothing would be left. Even Mars wouldn't be safe. While it wouldn't be swallowed whole, it would be roasted by radiation and scorching solar winds. Its frozen CO2 caps and underground ice would vaporize, briefly forming a ghostly atmosphere of steam and gas. But this wouldn't last long. The red giant's intense energy would quickly strip away that thin atmosphere. The Martian surface would heat past the melting point of lead, turning rock and dust into molten glass.
For a short while, Mars might glow like a burning ember, but it wouldn't survive the transformation. It would become just another scorched, lifeless rock. And as the red giant continues to lose mass, it would gradually loosen its gravitational grip on the outer planets. Jupiter, Saturn, and beyond would slowly drift away into the depths of space. So, how would we rate this apocalyptic switch? On a scale of 1 to 10 for sheer cosmic carnage, it's easily a 9. We're docking a point only because we wouldn't even have time to watch the destruction unfold. Swapping the sun for a red giant isn't just deadly, it's instant. Now that we've experienced complete annihilation, let's move on to something a little less fiery. Up next, we try out a red dwarf star and see if things can go a bit easier for Earth. If a red giant replaced the sun, Mars wouldn't be spared either. The extreme heat would cause its surface, made of rock and sand, to melt into a smooth, glassy puddle. For a brief moment, the planet would shine like a glowing ember, but that glow would fade fast as it turned into nothing more than a scorched, lifeless rock. Meanwhile, planets farther out in the solar system wouldn't escape untouched. As the red giant expanded, it would gradually lose mass, which means its gravitational pull would weaken. Planets like Jupiter and Saturn, if they weren't already fried, would begin to drift out of their orbits, slowly spinning off into the cold emptiness of space. So what would Earth's final moments be like in this nightmare scenario? Let's just say it wouldn't be gentle. On a how badly do we die scale, this ranks a solid 9 out of 10. We'd take off 1 point only because we wouldn't even get a moment to appreciate the view, just instant vaporization. Brutal, fast, and terrifying. But now, let's dial things down a bit. What if, instead of replacing our sun with a massive, deadly red giant, we swapped it out for a much calmer red dwarf? Unlike red giants, red dwarfs are much smaller and cooler. In fact, they're the most common type of star in the universe. Most exoplanets we've discovered so far orbit these dim reddish stars. And while our sun can never actually become a red dwarf because it lacks the right mass, imagine for a moment if it did. First, the skies would darken. A red dwarf emits far less light and heat than our current sun. Its surface temperature is only about 3,300 Kelvin, roughly 3,000 degrees Celsius or 5,500 degrees Fahrenheit. In Earth's sky, the new sun would appear as a tiny reddish-orange dot, like an eternal sunset, even at midday. It would be so faint that you could stare at it without damaging your eyes, though don't actually try that. With less light and heat, the world would begin to chill, fast. Within just 1 week, global temperatures would plunge below minus 18 degrees Celsius, or 0 degrees Fahrenheit. Within a year, Earth's average temperature would crash to around minus 73 degrees Celsius, or minus 100 degrees Fahrenheit. At first, there would be massive snowstorms and extreme weather, but soon everything would freeze. The water cycle would shut down completely. No rain, no snow, no wind. Without sunlight, plants wouldn't be able to photosynthesize. They'd die off first, and the rest of the food chain would collapse not long after. Only the toughest microorganisms, those hiding deep underground, or clustered around hydrothermal vents at the bottom of the ocean, might survive. But the Earth's surface, it would become a frozen wasteland. Eventually, even those microbes near the surface would go dormant or perish, turning Earth into a quiet, icy rock. Still, there's a slight silver lining. You wouldn't die right away. Unlike the red giant scenario, this one gives you some time. Time to build shelters, escape pods, maybe even find another planet, if you're lucky.
But there's one more twist. Red dwarfs are much less massive than our current sun, which means their gravity isn't strong enough to keep the solar system tightly bound. Over time, Earth might slip out of its orbit and become a rogue planet, wandering alone through the freezing darkness of space. And that change would be noticeable pretty fast. Since gravity works at the speed of light, about 8 minutes after our sun is swapped out, Earth would begin to feel the difference. It wouldn't be flung out of orbit right away, but it would slowly start drifting, eventually leaving the solar system altogether. So how does this one score? Maybe a 4 out of 10. A slow death is still death, but at least it gives you a fighting chance. Now let's try something rare, something most stars could never be. Let's imagine our sun transformed into a blue star. Blue stars may look cool and peaceful, but don't be fooled. These O-type and B-type stars are some of the hottest and biggest in the entire universe. They're true cosmic powerhouses. But they're also incredibly rare. O-type stars make up only about 0.00003% of the stars in the Milky Way. Our sun could never naturally evolve into one of these giants, but if by some cosmic twist it did, the results would be spectacular. If the sun were suddenly replaced by a blue star, Earth would be thrown into a dazzling, dangerous light show. Daylight wouldn't look the same. Everything would be bathed in a piercing bluish-white glow. The sky itself might shift to a much deeper shade of blue, or even violet, but don't let the beauty fool you. This star would be far more intense than our current sun. Staring at it directly, even for a moment, would be extremely harmful. The bright light would overwhelm your eyes, and worse, you'd be bombarded by massive amounts of radiation. Blue stars aren't just hot, they're monsters. Take Rigel, for example. It produces 60,000 times more energy than the sun. Some blue stars, like Eta Caterine, crank it up even higher, blasting out over 1 million times more energy. Even if our new star were on the smaller side of blue stars, Earth would still be hit with hundreds or even thousands of times more radiation than we currently receive. Just standing outside for a few seconds could give you a brutal sunburn. And in no time, Earth's surface would begin to cook. Instead of a comfortable average of 15 degrees Celsius or 60 degrees Fahrenheit, the planet would start heating up to temperatures that melt rock and metal. The oceans boiled away. Every living thing gone in flames. Earth's atmosphere would collapse under the weight of all that heat and radiation. It would be the ultimate wipeout.
Now, here's a tiny silver lining. If this new blue star had the same mass as the Sun, the planets wouldn't start flying off in different directions. The structure of the solar system would stay mostly intact. For a while at least. Mars might even warm up a bit. But don't get your hopes up. That much radiation would still make it unlivable. Building anything on the surface would be a death sentence. So if we were to rate the destruction level of a blue star replacing the Sun, it'd probably get a 5 out of 10. Not quite as showy as the red giant, but still a complete catastrophe. Now let's dial up the chaos and imagine turning our Sun into a neutron star. Neutron stars are the leftover cores of massive stars that exploded in colossal supernova blasts. These explosions are among the most violent events in the universe, releasing nearly all the energy a star has in just a second, enough to outshine an entire galaxy for days or weeks. Luckily, our Sun isn't massive enough to become a supernova, so let's skip that part and just pretend a neutron star replaces it quietly. Within 8 minutes of losing our Sun, the last rays of light would vanish, plunging the Earth into complete darkness. Stars would be visible in the daytime, but not the Moon or any of the planets. Those only shine by reflecting sunlight. You wouldn't even see the neutron star itself. It would be tiny and nearly invisible to the naked eye. From that moment on, Earth would be trapped in an eternal night. And without sunlight, photosynthesis would stop. Plants would die off, taking the entire food chain with them. Temperatures would crash as heat escaped into space. The planet would become a frozen wasteland. But the cold isn't the only threat. If the neutron star spins, and most of them do, it could become a pulsar, emitting powerful beams of radiation. These beams would sweep across the sky like cosmic lighthouses, hitting Earth with bursts of energy. You might see glowing waves in the atmosphere like auroras, but they'd come with a cost. Exposure to this radiation could destroy electronics, cause burns, and lead to radiation sickness. Life would be attacked from both sides, frozen by the cold and fried by radiation. But from a distance, the solar system's balance would remain intact. Neutron stars are roughly the same mass as the Sun, so the orbits of the planets wouldn't change much. But as incredible as neutron stars sound, they're deadly neighbors, too radioactive, too intense. On the destruction scale, let's call it a 7 out of 10. Now let's take it one step further. Replace the Sun with a magnetar. Magnetars are like neutron stars on steroids. They're just as small, only about 20 kilometers or 12 miles across, but their magnetic fields are the strongest known in the universe, 1,000,000 billion times stronger than Earth's.
If you're picturing a glowing orb in the sky, forget it. You wouldn't see anything. Magnetars mostly emit high-energy radiation, like X-rays and gamma rays, which are invisible to human eyes. Just like with a neutron star, you'd be living in constant darkness. No daylight, no moonlight, just black skies. And magnetars don't just radiate, they radiate heat. They're unbelievably hot, with surface temperatures so high they can scorch everything in their path without even being visible. Sure, all stars are hot, but magnetars take that to a whole new level. Their surface temperature can reach into the millions of degrees. You'd think Earth would be scorched by that kind of heat, right? Surprisingly, not so much. Magnetars mostly release their energy through dangerous X-rays and gamma rays, types of light our eyes can't see and our skin can't use to feel warmth. And because magnetars are incredibly small, barely the size of a city, their surface area doesn't give off much radiant heat to begin with. So while you wouldn't get warm and cozy, you would be blasted with deadly radiation. Earth would turn cold and dark, just like it would with a neutron star. But here's where things get even worse. Unlike a regular neutron star, a magnetar wouldn't just slowly freeze Earth. It would immediately fry our satellites, crash our power grids, and scramble our technology. Its magnetic field is absurdly strong, and it would wreak havoc on Earth's own magnetic field, the very thing that protects our planet from space radiation and keeps our atmosphere in place. Without that shield, radiation would pour in from all directions, blasting through everything. Not only would Earth go silent and blind electronically, but anyone on the surface might get so much radiation exposure it'd feel like stepping into a comic book origin story, except, sorry, no turning into the Hulk. That kind of stuff only happens in superhero movies. But hey, there's a silver lining. You'd get some stunning auroras lighting up the sky like never before, colors dancing across the atmosphere in waves of eerie, beautiful energy. If you manage to survive long enough to see them, that is. Magnetar, I'm giving that one an 8 out of 10 for sheer destruction and style. Now let's talk about something truly terrifying, the black hole. Remember how we said some of these exotic stars might actually be better than the Sun? Yeah, forget all of that. Black holes are a nightmare compared to our gentle, life-giving star.
But to keep things from instantly turning into a sci-fi horror scene, let's imagine that this black hole replacing the sun has the exact same mass. Not a supermassive monster, just a stellar-sized black hole with the same weight as our current sun. In that case, surprisingly, Earth's orbit wouldn't change. Gravity would stay the same, and our planet wouldn't get sucked in right away. Phew, right? But here's the thing. Our skies would never be the same. Where the sun used to shine, you'd now see nothing. No glowing ball of light, just a pitch black void. In fact, you'd only be able to tell something was there if you used a telescope. Then you'd notice that starlight behind the black hole bends and warps around it, creating strange effects like distorted star trails or, in special cases, perfect glowing rings called Einstein rings. It'd be beautiful in a haunting, cosmic kind of way, but that eerie beauty wouldn't keep you warm. Without sunlight, Earth would slowly freeze. Sure, the planet has some internal heat, so we wouldn't freeze instantly, but over time oceans would turn to ice, plants would die off, and eventually the surface would become a lifeless frozen wasteland. After a few million years, Earth's temperature would plunge to nearly minus 240 degrees Celsius. That's colder than you can imagine, just a few degrees above absolute zero. At least, I guess we wouldn't get stretched into spaghetti. That's what would happen if we did fall into the black hole, our bodies stretched and torn by gravity in a process scientists casually call spaghettification. So, replacing the sun with a black hole, I'd rate it a 6 out of 10. It's quiet, it's creepy, and you won't live long, but hey, you're not getting sucked in just yet. By the way, the closest known black hole to Earth is about 1,500 light years away. Not exactly next door, but also not far in cosmic terms. If you're thinking of jumping in to see what's on the other side, maybe a new universe, we would strongly suggest not packing your bags. That kind of trip belongs in a different episode, or another universe entirely.